crazy with how many students get tripped up by absolute value signs. If you're a student that's missed a problem like this on your exam, be sure to stick around until the end because I'm going to show you how to solve it quickly and how to understand it next time. For this problem here, you don't want to just drop the absolute value sign because you're changing the original function, and that's not going to work. And maybe you've tried breaking this up into two parts, which is correct, and you got stuck. We're going to work through that together right now. So usually when you see an absolute value sign, that's already a hint to you that you got to be thinking of boundaries. One boundary is when the absolute value of something is not negative, so 0 and above, or the case where it is negative, so less than 0. So let's start by letting x minus pi be greater than or equal to 0 for breaking this up into one part, dealing with the positive or non-negative integral. And so with this case, by solving for x, it's pretty simple, right? You get that x is greater than or equal to pi. Now remember, when you take the absolute value sign of x minus pi here, if x is at least pi or more, we know that inside of the absolute value sign, you've got something that is not even negative. So the absolute value isn't even doing anything. With that being said, you can just drop it in this case. Okay, now for cosine of the absolute value of x minus pi, for x is less than pi, we know in this case that some of you might be getting this wrong because when x minus pi is less than 0, how do we rewrite this in a way where we don't have this nasty absolute value sign that we have to work with? Think of it this way. Take 5 minus 2, for example. You get 3, right? Now, if you were to reverse the direction, you would get negative 3, right? If we know x minus pi is negative and we make an absolute value operation on it, give us a positive result, you can reverse that direction by just simply dropping the absolute value sign and putting a negative in front of x minus pi, right? This allows us to rewrite the expression without an absolute value sign, and I'm going to distribute this negative through to get negative x plus pi inside. Okay, so now for the original problem, what this means is we can break it up as a piecewise integral of two separate integrals depending on what boundary we're working on. In the upper case, we're dealing with non-negative values of x minus pi, and then for the bottom, we're dealing with the negative case. And so we want to now solve each integral individually. And before I do that, if you're finding value in my videos and you haven't, feel free to ninja kick that subscribe button and pick up some awesome swag in the descriptions below. So for the integral of cosine of x minus pi, what we're going to do is we're going to do a u-substitution. You could probably do this in your head. It's a pretty easy one. But in case you haven't seen it, you simply let u equal x minus pi. And taking the derivative of both sides, you get du equals dx. And now we substitute in u, which makes this a really simple integral of cosine of u du, which we know is sine of u. And then when you put back in what u is, which is x minus pi, you're going to get this result here, and making sure you don't forget this constant c at the end. Now for the other integral, this cosine of negative x plus pi dx, it's very similar. It's another u substitution. Now in this case, you got to be careful because when you let u equal negative x plus pi and take the derivative of both sides, the original expression has a dx, but here we have a negative dx. So you got to multiply both sides by -1 so that we can let dx be negative du when we do the substitution, which means that here you're going to be introducing this -1 term in front of du, so that when you integrate this, you'll get negative sine of u. And we'll put back in what u is, which is negative x plus pi, and making sure we have another plus c at the end of this integral. Now, what this means is that for the original problem, we can say that it is actually two separate integrals depending on what x is, right? If x is greater than or equal to pi, the result of integrating the first case gave us this sine of x minus pi plus c on top. And then for the case where x is less than pi, what I'm going to do here is I'm going to call this constant k because we don't want to necessarily say for sure that c